Good morning, girls. Today we are going to discuss about templates in C++, how to create function templates and how to create class templates. Now let us see what is a template. The main purpose of templates in C++ is to create generic functions or generic classes. The word generic means it accepts any type of data. In C++, we have two types of templates. We can create two types of templates. One is function templates and second one is class templates. Function templates are used to create generic functions and class templates are used to create generic classes. So now let us see what are function templates in detail. As already I told you, function templates are used to create generic functions. Now let us see what is a generic function. Generic function means we can use it for any type of data. For example, let us add two integers. Let us take the example of adding of two numbers. Now if I am adding two integers, the data type will be int. If I am adding float values, the data type will be float. And if I am adding double values, the data type will be double. So for each data type, you have to write a separate function. When we are using generic function, that means we will create a same function for all the data types. So here we'll have only one function code and we'll pass the data type as the parameter to the generic function. So if I want to add two integers, I'll pass int as the data type, if integer numbers. If I want to add two floating point numbers, then float is the generic data type I'm passing to the generic function. Then if I want to add two double values, then we'll be passing double data type to the generic function. Now let us see how to create a function template. So to create a function template, we have to use the statement template, open angle brackets, class, type identifier. Here type identifier represents the data type identifier, generic data type. So this statement is compulsory before defining a function. Now in this function, already we know how to define a function. The function header contains what return type value, that is the function, what type of value the function is returning, function name and parameters list, and body of the function. Now whatever the type identifier I have given can be used as the return type or parameter list or in the body of the function. Now let us see now this is a program where I've created a function template to add two numbers. Now in the main program, I have taken integer 2, values 3, double variables 3. Integer variables are a, b, c and double variables are I, j, k. So I have taken values for a, I have assigned values for a and b, that is 10 and 20. For double I, j, 11.012 and j 22.0. So a, b are double values, I, j are float values. Now when I call the function, see here I am calling a function c equal to a comma sum of a comma b. A and b are what type of values? Integer type of values. So the data type passed to the generic function here is int. So when that function is called, t is replaced by int. So wherever t is there, we'll get Here t is the generic data type. Generic data type is replaced by int. So it performs addition of two integer numbers and returns an integer. Return type is also t. That means it is also returning an integer value which is stored in C. Now I am calling the sum function. I am calling k. I am writing a statement k equal to sum of ij, where I and j are double values. So the data type here we are passing to the generic function is double. So t is replaced by double. So now the function becomes double sum double n1 double n2. So n here now n1 and n2 are double values. So the return type value will also be double. So whenever we call a function with a different type of values, for example, I am calling the sum function with integers, then t is replaced with integer. When I am calling the function with the double, t is replaced with double. Likewise, if I call the function with any other data type, then t is replaced with that data type. So here in this example, we have added two integer values and two double values, and so this is we have created a template function with one type. Suppose I want to take two generic variables, so that is also possible, that we can create templates by using function templates with multiple type. Multiple type in the sense I can take different type of arguments. So in the previous example, only one data type, t is either integer, double, or whatever value I am forwarding. So completely only one generic data type I have used in this example. Now let us say when with multiple types we can create a function template with different generic variables. So here I have taken t1 and t2 as the generic variables. When we are defining more than one generic variable, you can use the same format. Like template is a keyword we are going to use whenever we are going to define a template function or a template class. We are going to make use of the keyword template. Then we will open the angle bracket, then class identifier. So class is also keyword identifier. Identifier here is, here in this example I have defined two different generic identifiers, t1 and t2. So if I take this function is printing values of x and y, and here x data type is t1, y data type is t2. That means I can pass two different type of values to print function. Now this is the main function where I have taken I, j as integer values, float, f as float value. So when I call the first print function, I have sent I and j. I, j are both integers. So here t1 is replaced with integer, t2 also is replaced with integer. So here when I am calling the function, what are the type of the variables I am using, that will be defined for t1 and t2. Here when I call the print ij function, that is integer and integer, this is t1 is replaced with integer and t2 is also replaced with integer. Second, when I call the print function with j comma k, j here is, sorry girls, it is j comma f. J is integer, f is float. So here when I call that with the j comma f, that is integer and float, t1 is represented by integer, t2 is represented by float. Okay, when I call with f comma I, where f is a floating point value and I is an integer value. So here t1 is replaced with float, t2 is replaced with integer. So whatever the way function, when I am calling the function, what are the data types I am passing will be replaced with the generic identifiers. So this is to create function templates with multiple types. You can create more than two. In this example I have taken only two generic variables, but if you want, you can create more than 2 generic variables separated with commas. Every generic variable should be preceded by the keyword class and separated with commas. Now we'll see overloading, function overloading and function templates. What is the main difference between function overloading and function templates? Already in C++ we have seen a concept called function overloading. The purpose of function overloading is to create functions with the same name but with different signatures. So when I'm writing function overloading concept, I will be defining this function with the same name more than once. But in function templates, we will be defining function, only one generic function. We'll be creating a generic function and we will be defining identical operations. That is, when we create a generic function, what type of data I am sending from the main function, that type of data will be replaced by the type identifier. So here, if I want to create function overloading with function templates, okay, now here I have created a generic variable t. And this is already, we have seen the previous example. Only the difference is when I'm calling the function, I'm giving the data type. So that is when compiling itself, it tells the compiler that first sum function, if you see the first sum function, previously I have written k equal to sum of ij. Now I have written k equal to sum in angle brackets, less than, greater than, that is angle brackets. I have defined int. So now that means this function calls only integer values. This function is going to pass only integer values. Likewise, for next, when I am calling the sum function, then I am passing double. That means, that says this function can only pass double values. Okay, so same, only here the difference is I have mentioned the data type, integer or double. Now this is about function templates. There is a difference between overloading and function templates. Now we'll see what is class templates. Now previously we have seen function templates are used to create generic functions. Now class templates are used to, the purpose of class templates is to create generic classes. Now what is a generic class? The generic class is, we are going to define a class with generic data type. So whenever I am creating an object, I'll pass the data type. Okay, so here the syntax of the generic class, here you can see the syntax of the generic class. Like how function templates, we are using the keyword template. Like for generic classes also, that is class templates also, we'll start with the same statement, template with an angle brackets class keyword, then type identifier. Type identifier can be anything. Like in the previous function templates you have seen t, t1, t2, like that. You can give any type identifier, any character as a type identifier, or a group of character, any name. That is generally, that follows the rules for identifiers. Now here, this is the general form. You have seen this. Okay, before defining a class, I'm going to write a template statement and I'm going to define the generic data type. Okay, so here in this example, if you have seen this example, here I have defined a template class with the name item. So here t is the generic data type I am passing. So the data, the variable data is a variable in the class item which is of type t. Okay, and here you have seen I have written two functions, set data and print data. Set data function sets the data value and print data function prints the data value. Now when I call the set data function, I'll pass some value. That value, the data type of that value will be t, and that value will be assigned to data. So here wherever data type is required, I have used t in the place of data type t. So here whenever we are using class templates, we have to specify what type of object we are creating. Whenever we are creating an object, we have to specify the data type that is passed to the generic class. So this is the generic class. The class is item. Now this item class can accept integer data, can accept float data, can accept double data, and even can accept character data. So different types of data it can accept. The same class, but when we create an object, I can create an object for integer separate, I can create an object for character separate, I can create an object for float separate, and I can create an object for double separately. Now let us see object creation statement for this template class. Here I have created two objects, item 1 and item 2. Item 1, the data type here for item 1 is, I think all of you remembered the object creation statement. The syntax of object creation statement is class name, object name. Yes. Now here there is this small difference, because we are creating an object for generic class. I have to specify the data type. So here the syntax, the general form will be class name, data type within angle brackets, and object name. So when item 1 is created, int, the data type int here is passed to the item class. So item 1 represents integer data, item 2 represents float data. When I call set data function with I is an integer value. So that integer value is, so here when I call with this class with item 1, set data and get data, set data and print data. So both that wherever t is there, it is created by using integer. Now second, when item 2 is created, the data type is float. So whenever I've created an object with item 2 and I'm calling the functions with item 2, then here the data type is float. So now we'll see how to create with multiple types. Even in template classes we can create. Here in this example I've shown you only creating an object, creating a generic class with single type. In the similar way we can create a class with multiple types. So here you have seen the general form. So whenever we have multiple types, okay, the multiple types are multiple generic types are created by using different names separated with commas preceded by class. So this is the general form. Now let us see an example. Here I have taken two variables A and B. Now A is of type T1, B is of type T2. Okay, I have written a constructor. Then I have written a show function constructor. So in the first, when I'm creating an object in the main function, excuse me girls, test 1 and test 2 are the objects. Test 1 is the first object. I'm passing a float value and I'm passing an integer value. So T1 represents float and T2 represents int. Now when I'm creating test 2, I'm passing an integer and character. So T1 represents integer, T2 represents character. So first when I call test1.show, test1 I have given one float and one integer. First float, so t1 is float. Second is integer, so t2 is integer. So a value is here when I call test1.show, a is float, b is integer. So a and b are displayed, that is float and 1.23 and 123 are displayed. When I call test2.show, test2, here a is of type integer, b is of type character, that is t1 is of type integer, t2 is of type character. So a is an integer, b is a character. So these values are 100 and w. So a is 100, b is w. So now when I call the show function, 100 and w are printed. In this way we can create generic classes with multiple types. Here I have taken only 2, you can take more, depends on your situation. Okay, now we'll see inheritance. How this generic classes we are going to use it with inheritance. Whenever we are creating template classes, so classes generally we will use with inheritance. Suppose for example, there are here 3 instances, I mean 3 you can say 3 forms we are going to see. First one is base class, and when we have in inheritance we'll have base class and derived class. So here base class is not a template class, it's a normal class. Then derived class will be a generic class. Second is base will be template, derived will be normal class. In third case we have both base and derived as template classes. So okay, now let us see the first case where base is a normal class, derived is a template class. So in this format, like normal, here before the derived class I'll write the template statement. Okay, this is the general form if the base class is a normal class. Second, in the second situation, what I told you, that base class is a base class, that is a parent class. In this example I have taken parent. Parent class is the template class, derived class is a normal class. So here derived class is normal, but base class is template class. So before the base class I will define the template. Now here base class is a template class, so when I am deriving the class derived, I have to mention public base class name, that is parent, and the generic data type, whatever I am using the generic data type. Here t is the generic data type, so here t we have passed, t we have mentioned. Now here we'll see, this is the third case where both base as well as derived, both are template classes. So before base class I have to define the template statement, I have to write the template statement, and before derived class also I have to write the template statement. And here I have to mention what type of value I am passing to the base. So this is about templates, template classes and inheritance. I have shown you the general forms. Likewise, we can create the programs also. So this is about templates, girls. In the next session, we will see exception handling. Thank you.